Hi everybody, Physics Ninja here. Today what I want to do is I want to look at a problem, hydraulics problem that we solve using Pascal's principle. All right, so we're first going to review what Pascal's principle is, and then we're going to show you how to solve a problem where you have a tube like this that's filled with water or some incompressible fluid. And typically what you do is you apply a force on one end, and then you see what happens at the other end. And you can use a hydraulic system like the one I've depicted here to lift really heavy objects with only applying a small force. That's a lot less than the weight of the object that you're trying to lift. So we're going to review the important equations that you need to know for hydraulic systems that apply Pascal's principle. And then we're going to solve a problem. Let's solve an actual numerical problem where I'm going to give you the force and the dimensions of that cylinder, and we're going to calculate a bunch of stuff. All right, we're going to look at the work. We're going to look at the mechanical advantage, the pressure on both sides of this hydraulic system. All right, like with all my videos, if you like them, give it a thumbs up. Consider subscribing to my channel if you like what I do. Leave a comment down below. I'll try to get back to you as quickly as possible. All right, let's get started. All right, so first let's define what Pascal's principle is. Pascal's principle, and we're going to highlight just some of the terms here. It basically says that if you have a pressure change applied to a contained fluid, like the one I have shown here, it's contained by both of these pistons, a small one on the left and a bigger one on the right-hand side. That pressure change is transmitted undiminished, okay, at every point in the fluid and also to the walls of the container. All right, so let's see how we can produce a pressure change. Well, one thing we could do is we could apply a force to this side of our hydraulic system, right? Now, if you imagine that this is a circular piston over here, it's going to have a cross section, which is going to have a certain area. We're going to label that A1. Now, what are you going to get on the other side? Now, the reason you want a hydraulic system, first of all, what it does really is it changes the direction of the force. So you push down on this side, guess what? You're going to have a resulting force pushing up on the other side. Now, what we want to do really is kind of connect both of those forces, right? What happens if I push down with 10 newtons on this side? What do I get on the other side? Now, we're going to see in a second that, again, this side has a larger piston, right? We're going to say that it has a cross-sectional area A2, and in this case, clearly A2 is bigger than A1. Well, Pascal's principle says that this pressure is undiminished. So if I calculate the pressure on the left-hand side, it must be equal to the pressure on the right-hand side. All right, that change in pressure is undiminished. Now, if you remember the definition of pressure, well, let's apply it over here on the left-hand side. It's that perpendicular